Okay, in this first I do problem, we're going to calculate the volume of a 1.25 molar lithium chloride solution that can be made with 13.3 grams of lithium chloride. So we're going to use the formula given in this unit, and that formula is molarity equals moles of solute over liters of solution. So according to the 13.3 grams, first thing we have to do is really convert that to moles. So let's see here. So to find moles of lithium chloride, LiCl, we're going to take the mass, which is 13.3 grams of LiCl, and we know that 1 mole of lithium chloride has a mass of approximately 42.39 grams. Now that's going to give us 0.314 moles of lithium chloride. We want to calculate what the volume is, and we know what the molarity is. We're going to do a little bit of moving around this formula so that we can form uh, an answer for liters of solution. So I'm going to say liters of solution is going to be equal to moles of solute divided by molarity. Now we know moles, 0.314 moles of LiCl, and the molarity we were given up at the top as 1.25 molar solution. When we divide this out, we end up with 0.251 liters of LiCl. So that's the total volume of solution we would need to make a 1.25 molar solution using 13.3 grams. Another way we could set this up, and I'm actually just going to kind of take an eraser to this. See if I can do that over here. I'm going to use molarity as a conversion factor. So a second way you might set this up is to take that molarity that we calculated, the 0.314 moles of LiCl, and use molarity as a conversion factor. So the 1.25 molar is basically saying for every 1.25 moles of LiCl, we would have 1 liter of solution. So if I use that as a conversion factor and I flip it, so I have volume on top, it would be for every 1 liter of solution, I have a concentration of 1.25 moles. And you can see moles cancel out, and so you divide the 3.14 by the 1.25, which is exactly what we just did, but this time we're just using dimensional analysis to get our 0.251 liters of LiCl. Okay, second part of this problem, what would be the concentration of chloride ion in a solution that is made by dissolving 10 grams of zinc chloride, you've got the formula there, in a solution that has a final volume of 500 milliliters? So a couple different things. Notice that we're looking for the concentration of chloride ion. In other words, we're looking for the molarity of the chloride ion. And often that is written Cl minus with brackets around it. So that is going to be moles of Li, oops, wrong problem. No, let's go back. That's going to be moles of Cl minus. Chloride ion divided by liters of solution. The final volume I'm looking for is 500 milliliters, so that much I know. I've got 10 grams of zinc chloride, but that's ZnCl2. So a couple things we need to keep in mind is that when zinc chloride breaks down into ions, it's going to break down into zinc with a 2+ charge and then 2 chloride ions. What that means is if I've got 10 grams of zinc chloride, I have to figure out how many moles that is. And then I know I need to find moles of chloride, but there are 2 moles of Cl for every 1 mole of ZnCl2. So let's go ahead and let's calculate moles of zinc chloride. Since we have 10 grams of zinc chloride, and we know that 1 mole of zinc chloride, ZnCl2, has a mass of approximately 136.3 grams of ZnCl2. And I know that there are 2 moles of chloride ions for every 1 mole of zinc chloride, ZnCl2. I end up with 0.147 moles of Cl minus. Plugging that back into up at the top, that's going to be 0.147 moles of Cl minus over, we're going to change milliliters into liters, so that's going to be 0.500 liters. And that gives us a concentration of 0.294, and that's molar Cl minus. That's our final answer.